Hi. um, so let's get going with today's lesson. We're going to be talking about division properties of exponents today. Now, understanding these division properties of exponents, of course, allows us to simplify when we have quotients involving exponents. And just kind of think of these as shortcuts because writing out everything in expanded form would take a lot of time. So if we look here at this first method that's shown to us in the notes, one way to say what is 6 to the 6th divided by 6 to the 4th is to evaluate what each of those equal and then divide the results. So we could change both of those to their actual answer and then divide them. So we end up with 36 for our answer. Another way is to think about it in expanded form. So if you took 6 to the 6th and wrote it out in expanded form and divided by 6 to the 4th, after dividing out the common factors, you're still left with 6 times 6, which is 36. So if we think about how these would all cancel, and so you're just left with 6 times 6 still there. So when we look at this here, when we divide powers with the same base, all we need to really do is subtract our exponents. So we can kind of see that's what's going on here. If we take 6 minus 4, we get 6 squared, and 6 squared is 36. So it's kind of a shortcut way to do division problems with exponents, okay? So we can see here, this is what we would do instead. We would just subtract the exponents to get 6 squared, which would give us 36. So all of those methods work, but knowing this shortcut, this little short method, allows us to deal with much larger exponents as well. So let's look at the next example here. It also works, of course, with variables. Again, if we cross out the variables or the x they have in common, we're still left with x squared. And again, 5 minus 3 is x squared. So the main rule that we'll start with today is that when you're dividing with exponents and they have the same base, then we're going to just subtract the exponents. And it's always the top exponent minus the bottom. It's always the numerator exponent divided by the denominator exponent. So it's always that same way. And here we can see some examples. So to divide powers with the same base, we simply need to subtract the exponents. And it works with numbers, it works with variables, it works with fractions, all of that. So if we look at this example here, we're just going to subtract. So think of that 1/2 as 2/4. I'm going to go ahead and change it to 2/4. That way when we subtract, we're really just taking 3/4 minus the 2/4. And that would leave us with 1/4. So y is equal, so it simplifies to y to the 1/4 power. And of course, that's just kind of that basic understanding, a basic problem, and they can get more complex as we go. We can also see how it's used in scientific notation. So we know that during one year, Honduras had a population, and it was given by this in scientific notation, that many people. And then the area of Honduras is this many square miles. So we want to know what the population density was at that point, that year. So think of this as we're dividing the number of people by the square miles, by the area. So I'm going to write that out here. And what we would do with the values, the numbers, is we would divide those like normal, and then we would subtract our exponents with the like base. So we would end up with 1.69 times 10 to the second power. Or we could think of it as 169 people per square mile in that particular case. So it works with scientific notation as well. Now let's look at another property with division. In this property, we're talking about raising a quotient to a power. So again, I think of this one also as distributing, because we have to distribute the exponent to the numerator and to the denominator. So it's really 3 to the 4th over 10 to the 4th. And then, of course, we could simplify it from there. So 81 over 10,000. Okay. So if it's not in parentheses, though, we would not distribute it to both the numerator and the denominator. So the parentheses show that we're doing the whole quotient to the power. Okay. Okay, we're going to move on here and look at example 3. So here we're raising this quotient to the power of 4. So that means we're going to multiply it to the numerator and to the denominator. We have to multiply those. So 3/4 times 4, that would give us 12/4, which is 3. So I'm going to just write it out here just to break it down. A to the 5th times 4. So we would end up with a to the 3rd over a to the 20th. And now we can see that they have the same base. So now we would subtract, and we always subtract the top from the bottom. So that would give us a to the negative 17th. And we can't have a negative, so then we have to flip it. So our final answer is 1 over a to the 17th. Okay. So let's look at another problem here. Now in example 4, we're still simplifying an exponential expression, but we have to think about how we would start this. Now there's a few ways you could start this. You could go ahead and distribute that -2 to the top and the bottom of the quotient, or you could flip it first to get rid of the negative. You could flip the whole fraction. So let's go ahead and do that. We're going to flip the whole fraction there. And now we have a +2 there because we flipped it. Well, it works. So then we have to distribute that to the to the top and the bottom. And when we do that, remember the 2 has to go to the whole product if there's more than one value. So we would actually say 5 squared b squared all over a squared. So it's got to distribute to everything. And then we could simplify it a little bit more. So we could say 25b squared over a squared. And we can't simplify that anymore because we don't have like bases. So at that point, we're done. Remember, as I go through the notes, you can always pause or go back if you want to hear an explanation again. You know, it's a good way to, since you have the notes on video, to go back and review things if you need to, okay? So we have a lesson check here that just kind of reviews the properties, the two properties, but we also added in a few extra problems at the end because the book doesn't give a ton of practice. So we have 3 problems here at the end that we've added, problems 5, 6, and 7. And what I would like you to do is try each of these first. And so you can pause the video, try those problems first, and then when we unpause, we'll come back and you can check your answers with my answers, just to make sure you're on the right track before you get going with the assignment. Okay, I'm going to pause here and go ahead and work those out, and then we'll see some of the different types you can check your answers. Okay, so let's look first at problem number 5, and I kind of have that started already here. So we want to distribute the 3 to the numerator and the denominator, and since they already have an exponent, that means we're going to multiply. Think of it as a power raised to a power. We have to use that property. So we're going to multiply those. So we would get 3 to the 6th over 3 to the 15th. And then our next step is to subtract because they have the same base. So think of it as 3, 6 minus 15. And that would give us a negative value. So 3 to the negative 9th value. And we can't have a negative, so we would flip it and say 1 over 3 to the 9th. And since my exponent is larger than 5, we'll go ahead and just leave it as 1 over 3 to the 9th. So check your answer and see if that is what you got for the first one. The second one, again, I already kind of started it. So the 25 over 5, we can treat that as just a division problem. So that simplifies to 5. And then we would have to, again, subtract the top exponent from the bottom. So that's going to be negative 9 minus negative 14. So that would end up being to the 5th. So we would end up with 5 and then b to the 5th power. Sorry, I've got to correct something on my key there. So the 5 would carry over, and that becomes a positive 5, and then that's all we can do on number 6. So again, check your answer and see how you did. The last one here, example 7. So again, I already kind of started it. 7 over 14, we know that simplifies to 1/2, so I went ahead and did that. And then again, I took the top minus the bottom exponent. So again, I don't have to write the 1, but I have to remember there's a 2 there still. And we end up with x to the negative 4th power. And we can't flip the whole fraction. Remember, we can only flip the number that has a negative exponent. So that 1 actually comes in handy again because we'll have to still have a 1 here. The 2 stays where it is, and the x to the 4th flips to the bottom. So that goes to the bottom. So you end up with 1 over 2x to the 4th power. Those are just, as I said, some extra examples since the book doesn't really go into a lot of those explanations. And you can kind of see the different types of problems you could have and how sometimes, like in problem 5, you have to use multiple rules that we've learned previously. So like I've been saying, the more rules we learn, the more complex we can make the problems. Okay, so that's the end of our notes for today. And next is to get started on the homework. See you guys later.